At this point, you should know that if you are looking at a linear function, we have f of x equals mx plus b. A linear equation, we have y equals mx plus b. So this model that we have here is a model, it's a linear model. So the x again is our input, f of x is our output or our y. Okay, so f of x is our output quantity and x is our input quantity. So the graph of f is a straight line with slope m and a vertical intercept or the y-intercept. Again, the vertical intercept is known as the y-intercept. And for vertical intercept, remember, x is always 0, or for y-intercepts. Okay, x is always 0. X is always 0. Again, the brain behind the y-intercept and x-intercept, I'll talk about that in a few. Now, given any 2 points, you should be able to find the slope. So look at these 2 points here. X1, y1 as 1 point, and then x2, y2 as another point. So these 2 points are on a line. Okay, the change in output, that is the y values, the change, if you subtract those two, okay, you subtract y2 from y1 or y1 from y2, and then you do the same for the input. So if I do y2 minus y1, I have to do x2 minus x1. If I do y1 minus y1 minus y2, I have to do the same at the bottom, x1 minus x2. No matter how you do it, you're going to get the same thing. Y2 minus y1 divided by x2 minus x1 is the same as that, same thing. Both of those is going to give you the same answer, which is the slope. So the slope is the change in y over the change in x. Change in y over the change in x. And that is what we have here. Change in y, delta y over delta x. All right. Now, what we have to also remember is that when m, or the slope, is greater than 0, the graph increases from left to right. When the slope is greater than 0, the graph increases from left to right. When it's less than 0, the graph decreases from left to right. Remember that in lesson 1, I talked about the fact that we read these graphs from left to right, like reading a book. So if the slope is greater than 0, it increases from left to right. If it's less than 0, it decreases from left to right. If it's equal to 0, then it becomes a constant function. The graph is going to be a horizontal line, okay? A horizontal line. All right. What about the domain? What about the domain? What about the domain of a function? So, for the domain of a linear function is generally is all real numbers. All real numbers. And all real numbers, that is negative infinity to what? Positive infinity. All real numbers. All real numbers. Okay? All real numbers. All real numbers. All right? Okay. Now, sometimes you might have a practical domain. A practical domain. And when that happens, the domain is not going to be all real numbers. Okay? Depending on what the problem says, you have to find the domain. Now, to calculate for the vertical intercept, remember x is always 0 for vertical intercept. And I said I'm going to explain that in a little bit. So let's go to the whiteboard And let's talk about that. Now, if I have my plane like this, and then I do this, I get a straight line. Now, intercept, the word intercept, it's like cutting through something, right? An obstruction through something. So if I say that y-intercept or vertical intercept, what do I mean by that? What I mean is I'm looking at the point on the vertical line or the y-axis where the line or the graph cuts the y-axis or the vertical axis. That is why it is called the vertical intercept or the y-intercept. And this is it right here. It cuts, the line cuts or the graph cuts the y-axis at that point. So if this point I have 2 here on y, what is the point going to be? What is the ordered pair going to be? So you know that at this point, x is what? 0, and then y is 2. Because the point is on the vertical axis or the y-axis, you know that x is 0. So x is always 0 because on a point on the vertical axis or the y-axis is going to give you x equals 0. So x is always 0 for the vertical or y-intercept. So if you have an equation of a line like this, y equals 2x plus 5, and you are supposed to find the y-intercept or write the ordered pair for the y-intercept, you know that your x is 0. So x is equal to 0, that you know. So to calculate for the y value or the y-intercept, I have x is 0, I put it in, equals to, wherever I see x, I put a 0 plus 5. So this would give me 2 times 0 is 0 plus 5. This gives a 5. So the y, or f of 0, y which equals f of 0 equals 5. So my y-intercept is 0, 5. So if this is 5, then it's going to be somewhere here. And it means the line should go that way. Okay, that is y-intercept. That is y-intercept. Now, what about x-intercept? Again, same concept. But this time around, we are looking at where the line cuts the x-axis. The x-axis. Okay, we are looking at where it cuts the x-axis. So again, I'm going to draw this and do that. And let me put 4 here. So I'm going to have this. Again, on the x-axis, y is always what? 0. So at this point, I have my x-intercept or the horizontal intercept. Why? Because that is a horizontal axis. So y is always 0. Y is always 0. So let's say that if I have f of x equals 2x plus 4, because I know that my f of x equals y, then it means that for x-intercept, y is always 0. So f of x, this whole thing will go to 0, equals 2x plus 4. Now I'm trying to solve for x, right? Because I already know my y. I need to get my x here. So I could move this here or do a -4 on both sides, right? -4 on both sides, or you move that across the equal sign, that turns to a negative, and then I have my 2x. I divide by 2, I divide by 2. What is x equal to? This goes into itself 1 time, 2 times, x equals -2. So that becomes my what? My y-intercept, which means that, if this is a -4, if I have -2 here, then we are looking at a line that goes through that. That's what we are looking at. That's what we are looking at. X equals -2. Okay, so it's y and x intercepts. Y intercepts. All right, let's keep going. Let's go back to the file. All right. So again, here, I already talked about the intersect. Yep, I already talked about all that. And remember that from what we have here on top, f of x equals mx plus b, right? M is the slope. You have your x there. X has to be there, right? Because x is the input. And then the b would also be there. There is one thing I have to talk about with y-intercept, but as we go on, I'm going to talk about that. So if f of x equals mx plus b, so the m is a slope, that is a number. The b is also a number. Okay, so for x-intercept, y is 0, so we have 0 equals mx plus b, like what I did, a few minutes ago. Again, the m is a number, the b is a number, but the m is always the slope. Okay, and then we have the b as the y-intercept, or the vertical intercept, but I would explain that in a bit. All right, so let's look at this problem. With this problem, we have a practical problem. Again, you have the workbook, so you could turn to this page or look for this problem. So the function e of t equals 3861 minus 77.2t gives the surface elevation in feet above sea level of Lake Powell t years after 1999. A. Identify the vertical intercept or the y-intercept of this linear function and write a sentence explaining its meaning. Write a sentence explaining its meaning in this situation. All right, so first of all, we are supposed to find the y-intercept. Now, from what we have here, we have E of t equals 3861 minus 7.2 t. Is this a linear function? Yes, it is. Why? Why? I don't have that space, but try and follow me with this. We have linear function always being of this form, right? F of x equals mx plus what? B. Now, if you look at this, there is a little bit of change. The function e of t here tells us that our input is t, not x, which is fine. So we've replaced x with a t. Now, when you get in here, you could see that the b is that, because that doesn't have an x attached to it. And then my m, which is my slope, is this. And then I have my x, which is a t. So this can be written as e of t equals minus 77.2 t plus what? 3861. minus 77.2t plus 3861, which I could write this mx or mt plus b. My m is that, my x is t, and then my b is that. So it is a linear function. It is a linear function. All right. So that said, how do I find a vertical intercept? I'm going to go to the whiteboard. We're going to use that. So I'm going to rewrite this on the whiteboard. 3861 minus 77.2t. So let's go back to the whiteboard. Oops. So I have E, oops, T equals 3861 minus 77.2 T. And this is what we can rewrite it as ET equals negative 77.2 T plus 3861. We are finding the y-intercept or the vertical intercept. Because it's y-intercept, x should be what? 0. We know that. So here we could say t rather should be 0. So E, then you put your 0 in there. You have negative 77.2. I put 0 there for t plus 3861, like that. Now, if I do the multiplication, negative 77.2 times 0, any number times 0 is 0. So this equals 0 plus 3861. So this equals 3861, like that. When x is 0, y is what? 3861. Y is 3861, which means that ordered pair for the y-intercept is this. Now, for the y-intercept, usually just by looking at what you have for the function, you should know what it is. So clearly you could see that it's this number for my y, right? And x is always 0. Why? Because if you have a linear function like this, a practical one like this, you should know at this point that if I put in 0 for my x or my t, everything is going to go to 0 here. So what I'm going to have left is this. So anytime you have something like this, you should always remember that I'm going to erase this. Oops. Let's see what I can do with this. Okay, let's go. Yep. So anytime I have y equals mx plus b, my y-intercept, oops, will be 0 for x, that we already know, and then I put my b here. Okay. So if I have y equals 2x minus 5, my y-intercept is going to be 0, negative 5 of that. That is my y-intercept. Okay, that is my y-intercept. Why? Because the rule says there is a plus here. So whatever is here, if it's negative, because positive times negative is still negative, so I put everything on here, negative 5. The only problem with this is that sometimes you might have a function like this, 2x equals 6. Oops. You might have a function like this, 2y equals 4x minus 6. Now, for this, you don't have to quickly go and say this is the y-intercept. Y-intercept is what? 4, negative 6. No, this is wrong. Why? Because you have to get y here, not 2y. So I do this. 4x minus 6. I divide through by 2 for all of them. So this will cancel that. I have y equals, this will cancel this 2 times, this will cancel this 3 times. So I have 2x minus 3. So the y must stand alone. So therefore I have y-intercept being there. Okay, so that is one important thing you have to know. That is one important thing you have to know. All right, so let's go back to the file. So going back to it, so I could say that the y-intercept or the vertical intercept is that 3861. We already calculated for that. Now it says that write a sentence explaining its meaning in this situation. So this means that, what does this mean? Since remember from the problem, it says that we are looking at the surface elevation of Lake Powell T years after 1999. Okay, T years after 1999. Now, because T is our X, right? T is our input. T is the time. When T is 0, what does that mean? It means we are in 1999. Okay, because we are starting from 1999. So 1999, T is what? Time is 0. In 2000, you will be 1 year old, or the lake, or the surface elevation, we are looking at 1 year old. 2001, we have 2 years, and it keeps going like that. So when T is 0, we are in 1999. So what this y-intercept means is that in 1999, which is 0 years after 1999, the surface elevation of Lake Powell is 3861 feet above sea level. That is it. So in 1999, the surface elevation of Lake Powell is 3861 feet, or 3,861 feet above sea level. So you can write that in your workbook. Okay. Now B, determine the surface elevation of Lake Powell in the year 2001. Show your work and write your answer in a complete sentence. So again, just explain that if we are in year 2001, then we are looking at T equals 2 years. You don't have to say T equals 2001. That is too big, right? So from 1999 to 2001, you know it's 2 years. So T is 2 years. So this allows me to do E, my T is 2 of 2. So I'm picking the function from here. Okay, when T is 2, what happens? We have 3861 minus 77.2 times what? 2, like that. So from calculator, 3861 minus 77.2 times 2 is 154.4. What does that give us? 3706.6 feet. So writing this out as a sentence, in 2001, the surface elevation of Lake Powell is 3706.6 feet above sea level. In 2001, the surface elevation of Lake Powell is 3,706.6 feet above sea level. So you write it out, okay, in your workbook. All right. Now, what about C? C says determine E of 4. So that means T is equal to what? 4, because we put it in for us. And write a sentence explaining the meaning of your answer. So E of 4, again, you do the same thing. 3861 minus 77.2 times 4, like that. So this should give us 3861 minus 308.8, which gives what? 3552.2 feet. So 3552.2 feet. Now, what does T equals 4 mean? So if you are looking at from 1999, 4 years after 1999, that takes us to 2003. So in 2003, which is 4 years after 1999, the surface elevation of Lake Powell is 3,552.2 feet. In 2003, the surface elevation of Lake Powell is 3,552.2 feet above sea level. All right. Okay. Now, what about D? What about D? What about D? What about D? So D says, is the surface elevation of Lake Powell increasing or decreasing? So look at it. When T was 2, in 2 years, we had what? 3706. When T was 4, we have 3552.2. So it's what? It's decreasing as the years increase or as the years go by. It's decreasing. Now again, if we go back to what we started with, we said that when the slope is less than 0, the graph would what? Decrease. It's going to decrease. Okay, it's going to decrease. Now, if you look at this function, I'm going to go to the whiteboard. E of t equals 3861 minus 77.2 t. Now, we could rewrite this if you want to. You don't have to. E of t equals negative 77.2 t plus 3861. Now, if you compare this to f of x equals mx plus b, what is my m? What is my slope? Negative 77.2. So slope m is less than what? 0. It's a negative number. So it means graph is what? Decreasing. So you could use the slope is decreasing, sorry. It's decreasing. Okay. Graph is decreasing. All right. Again, if you have any questions, put them on the discussion board. All right. Again, you could also look at what we saw so far. E of 2, when t is 2, when t is 4, you could see that as the years increase, the graph decreases. Or as the years go by, the graph decreases. You could clearly see that. Or you could use the slope. Look at the slope, and then it should tell you it's increasing or decreasing. All right. So how do you know? You could say that from the slope, you could use the slope. Okay. E, the function accurately models the surface elevation of Lake Powell from 1999 to 2005. Determine the practical range of the linear function. The practical range. What is the range? Remember, with the range, we are looking at the output values, right? The set of output values. Here, we are looking at a practical range. Why are we talking about practical? We are talking about practical because this is a practical problem. Okay, this is a practical problem. So that is why we have to talk about that. That is why we have to talk about that. All right. Oops. So what is the practical range going to be? Again, finding the practical range, remember the input affects the output because the output depends on the input, right? The output depends on the independent. which is the domain or the x values, right? So how can we find practical range in this situation? How can we do that? And I guess that's a very good question. So from 1999 to 2005, so 1999, we know that t equals what? 0. 2005, t equals what? 6. So this gives us kind of a practical what? Domain. This is domain, right? Because it's the x values, the input values, independent values. From 0, that is at 99, to 6, which is 2005. Now, the range is going to be the output values. So we could only get the practical range by using this practical domain 0 to 6, calculating for t equals 0, or calculating for the surface area t equals 0, and then when t equals 6. Right? Because the range must be from when t equals 0, or the surface area when t equals 0, and the surface area when t equals 6. So the practical domain gives us our range. So if you go back to the whiteboard, we know that the practical domain, for that problem, it says from 1999 to 6. So we know that domain is going to be that, because we are restricted. All right, it's going to be negative because there's a practical thing. Time cannot be negative. So E, when t equals 0, this is what I have, 3861 minus 77.2 times 0, which equals what? 3861. That we already calculated for. And remember, what is this? This is what? The y-intercept. Why? Because x equals what? 0. It is the same as the y-intercept. So this we have 0, 3861. Okay, and that is what we calculated first for A. Then what about when t equals 6? Oops, when t equals 6, t equals 6. Here is t equals 0. When t equals 6, I'm going to have 3861 minus 77.26. What does this give us? 3861 minus 463.2. And this gives us 3397.8. So what is the practical range going to be? It's going to run from what? 3397.8 to what? 3861. Practical range. And we find the practical domain to get the practical range. To get a practical range. All right. So let's keep going a little bit. Back to the lesson, or back to the file. So let's talk about the average rate of change. The average rate of change. So average rate of change of a function over a specified interval is the ratio. What ratio is it? Change in output over change in input, and that is the same as the slope. That is the same as the slope. Change in output divided by change in input. Change in y divided by change in x. Units for average rate of change are always output units divided by input units. But remember, for the slope, there is no unit. That is the difference between the slope and the average rate of change. The slope has no unit. The average rate of change has units. But with the value, it is the same thing. With the value, it is the same thing. No difference. No difference. So it is something we should bear in mind. Now, this is a media example, so I'm not going to spend much time on it because I think that you should watch it. Okay, you should watch it. Now, here we have 1999 because it's 0. Here we have 2000, and then we keep going, right, to 2005. To 2005. Okay, and we have 3861 here. We have 3783.8 here. You keep going till we get to 3397.8. And you know how to find these. I just did those. Okay. Now determine the average rate of change of the surface elevation between 1999 and 2000. So we are looking at from 1999, t equals 0, and then t equals 1, right? 1999 to 2000. Now we know that the average rate of change is the slope. It's a change in y over change in x. Change in y over change in x. So we could do y2 minus y1, x2 minus x1. That's it. Equals the average rate of change. Average. Okay. All right. So what is our y2? So we can pick this guy here as y2, pick that here as y1. If that happens, then we don't have an option than to pick this as x2 and then x1, right? Same thing. So we input these into our function. Okay, we input this into our formula, into our formula, and see what we are going to get. All right, again, this is a media example. Go to my open math and then watch this. Watch it. All right, watch it. So with this formula, because I don't have much space, I'm going to clear everything. So for this one, we have 3861. So y2 minus y1, if this is my y1, and then 3783.8 is for that. This is my y2, this is my x1. So this means that from the formula I just wrote, y2 minus y1, I'm going to have 3783.8 minus 3861 all over. X2 minus x1 is 1 minus what? 0, which equals the average rate of change. Now, when you put this in a calculator, you should get minus 77.2. Minus 77.2. Remember, that is the same as the slope, right? That is the same as the slope. It's right here. It's right here. Okay, negative 77.2. But because it's average rate of change, you have to get units. So remember, t is in years, and then the surface elevation is in feet. So feet over what? Years. Goes 1 minus 1. Okay, feet over years. And then you go to B, also says find the average rate of change of the surface elevation between 2000 and 2004. 2000 and 2004. And 2004, I think, is right here. That's 5. And then 2000 is here when t equals 1. Okay, so you have to calculate for what you're going to get for this, and then what you're going to get for the surface elevation when t equals 1. How to do that, I just explained that. If t equals 5, you put that in the function, you get your numbers, okay? And then you use those y2, y1 to solve that. Go to the video lessons and you should be able to see this. You should be able to see this. All right. So average rate of change is the same as the slope, only that the average rate of change has units. So you have to put in the unit for average rate of change. Okay. and this is equal to the rise over run. Why do we say rise over run? Rise over run. So remember that with y2 minus y1, x2 minus x1,